Hello everyone. Today I will be discussing the paper that is used for recording ECG. So I have made a diagram of that, and you can see that this paper, the ECG paper, it is divided into squares. Okay, so there are some small squares and then there are some thicker lines which divide it into some larger squares. So this each small square, it is 1 millimeter in length and 1 millimeter in breadth, and each large square is 5 millimeters in length and 5 millimeters in breadth. So on the horizontal axis, we see in this horizontal direction we plot the time. Okay, so the speed of the ECG paper is 25 mm per second. So you can count these 25 small squares or 5 large squares, they would count as 1 second. So this much of a duration from this point to this point would be 1 second. Okay, 5 large squares or 25 small squares, that will make 1 second. Okay, and about the voltages, vertically you can see the voltage. So this 10 mm or 10 small squares or 2 large squares, they constitute 1 millivolt. Okay, so you can on depending on the ECG tracing, you can talk about the rate of the heart rate, you can say, and you can also talk about the voltages that are occurring. These voltages are very small in relation to what voltage changes they actually occur in the heart, because they have to be conducted to a large distance. You know, the leads are placed on the arms or on the chest, so the voltages are not totally conducted to that part. Much of them are lost, so these voltages are of a smaller degree. Okay, anyways, this was about the paper. Now I will be discussing the ECG leads. I had discussed about 3 ECG leads, that is the bipolar limb leads. I had discussed about that, and in those I had told you that they are aligned at an angle of 60 degree to each other. So it was somewhat like this. Okay, this was lead 1, lead 2 and lead 3, and these were the positive deflections in these. Okay, and correspondingly the negative were on this side. Now in addition to these bipolar limb leads, we also have unipolar limb leads and unipolar chest leads. Okay, the unipolar limb leads are 3 in number, and the unipolar chest leads are generally 6 in number. So we have a total of 12 leads. Okay, so how are these unipolar leads formed? For that you need to know about the concept of a Wilson central terminal. Okay, and this Wilson central terminal, it defines the indifferent electrode, or the electrode which is said to have be in a zero potential or a zero reference point. Okay, and that becomes zero, and the other lead is called as the positive lead. So such type of leads, they are called as unipolar. Okay, now how this central terminal is formed? It is formed by, you know, the limb leads, they are attached at the right arm, the left arm and the left leg. Okay, if I take one electrode from here, from the right arm, and connect it to a resistance, and this resistance is 5000 ohm. Okay, similarly from the left arm, again a resistance having the same value. Okay, and from the left leg also a resistance having the same value. Okay, now all these three connected together will form one terminal. This is the indifferent electrode. Okay, and then the positive electrode could be either of the limb or a place in the chest. This is how the unipolar leads are composed. Okay, so talking about the unipolar limb leads, now connecting these 3 points to one terminal and then taking the positive electrode, say from the right arm, so that would be called as VR. Okay, and if you are taking the left arm as the positive electrode, it will become VL. Okay, and if you are taking this, it is called as VF if you are taking the leg. Okay, so right, left and foot. Okay, but these leads, you will find that they are called as augmented. Now why, what is the concept of augmented leads? That is, in the indifferent electrode there were 3 electrodes connected together and the positive was given by either of the 3. Okay, now if you cancel out that particular electrode from which you are making the positive electrode, the voltages in that are increased, in that lead are increased. So what was VR, if you remove this from the indifferent electrode, the right arm, and only connect it to the positive terminal, this will become augmented VR or AVR. Okay, similarly, if you from these 3 electrodes you cancel out this electrode and only connect it to the positive terminal, this will become AVL. Okay, and in the left leg, if you cancel out this from the negative and only connect it to the positive, it will become AVF. Okay, and the benefit is that they provide you a little more voltage, a 50% increase in the voltage which is seen in these leads. Okay, now what will be the direction of these 3? Now, we had discussed about equilateral triangle, Einthoven triangle. So talking about AVR, so the positive terminal is somewhere over here. The indifferent electrode or the negative terminal would be composed by an addition of these 2. Okay, so I will redraw it. For example, this is the right arm, this is the left arm and left leg. So these 2 are forming the negative terminal. So you can take a resultant of these 2, which would be somewhere around here. Okay, and this, and since this is the positive electrode, the axis would be somewhere like this. Okay, fine. Then about the left, this was about the AVR. Now about the AVL, these 2 will form, for AVL, these 2 will be forming the indifferent electrode and the axis would be somewhat like this. Okay, and for AVF, these 2 will be forming the indifferent electrode and the axis would be somewhat like this. Okay, so now we have got, in addition to these, the triaxial system that I discussed, we now have got a hexaaxial system. Okay, and you can add on to this, the AVR would be having a direction here in between 1 and 2. Fine, and its positive vector is here. Fine, then this I will write it as AVR. Okay, then in between lead 2 and 3 we have got another lead, and this is AVF, and its positive direction is here. Okay, and between 1 and 3 you have got another one, which is AVL, and the positive direction is towards that side. So this becomes AVL and the positive direction is here. Okay, so this is what we call as the hexaaxial system of limb leads.